Okay, good afternoon, class. We left off at problem 9 yesterday. So let's go ahead with this. We have, for the inverse function of x for the given function f of x, use composition to verify that the functions are inverses. Now, composition is one thing that we didn't learn this year, and it seems strange that the book would ask us to do something it hasn't taught us how to do yet. Okay, so we might set this aside, but definitely the pre-calculus people are doing that this year. If you look at the graphic organizer, like you have there, Connor, on your desk, I've mentioned something about composition on the upper left. Related. Yeah, composition related. That's what this is. So anyway, we have a 4-step process here. The first of which is to go ahead and make this a y equals negative 3x plus 3, right? And the next step of which is to, what do you say? To switch x and y. Okay, Gabby, very good. Okay, and then solve for y, right? Which is going to be subtract 3. So we get negative 3y equals x minus 3. Does that look right? Okay, then what do you think, Riley? What's going on next?
Divide by 3.
Divide by 3, Riley says. Negative 3, he says. Does that sound right? Okay, is Riley right about this? Yeah, he's right. So we have y, and the only other thing I could recommend is trying to put this into slope-intercept form. So how do we put this thing into slope-intercept form here?
Negative 1/3 x.
Okay, Connor says negative 1/3 x. Does everybody see that? Okay, looks good. And then what else? Plus 1. And then we have finally, in inverse function notation, why is this form helpful to us here in this problem? Because we're going to graph it, and this form is called the what form? What form do we call this? Okay, we call this the slope-intercept form, okay? Which, as Ben says, I think it makes the thing more easy to graph. And then, so you can go ahead and graph these, and I'm going to graph this first one up here. So where do we start? 3, right? And then we have a slope of negative 3, so that's down 3 over 1. So the thing's going to look something like this. Okay, that's about as good as I can do it. Okay? And then, so now, to graph its inverse, how do we graph its inverse? Well, same thing. We go up to the y-intercept, right? And then what's the slope? Negative 1 over 3. So here we have this kind of looking thing here. So we have something that looks like that. Not the best drawing, but you get the idea, right? Okay, do these functions look like they're inverses of each other? Right, reflects about the line y equals x. Okay, so we have this. I want to briefly mention, as far as composition, for a composition of functions would be like f of g of x. So I'm going to do a composition here, and for f of g of x, we're going to put this, we'll say this right here is g of x, and f of g of x, we're going to put this function inside of this one here. So we're going to have -3, and then in the place of x here, we're going to put -1/3 x plus 1, and then we have this plus 3. So you see what I did? In the place of this x here, I put this whole function right in here. Okay, and if we work to the right and simplify this, we get -3 times 1/3 is what? -3 times -1/3 is 1, okay? So this is going to cancel out here. So what we're going to get here is x, and what's -3 times 1? -3, and then we have plus 3, and what does this simplify to? X, okay? So this is a composition check for that, and that's one that, again, the book hasn't taught you to do yet, but that's what that is, okay? Next, I want you to do number 10. Can you do that? Okay, what I did is I wrote up here the first 2 steps. Does that look right so far? And then solving for y. This looking thing here, right? So we have 2/5 y equals x plus 2. Does that look right? And then what next? Multiply, what do you say, Connor?
Fraction.
Okay, what do we do to wipe out this fraction here? Reciprocal, right? So let's multiply by reciprocal. So we multiply by that, and what do we have to do to the other side? Same thing, right, Jay? So that goes away. So we have y equals 5 over 2x plus 5/2 times 2 plus 5, right? And so we get f -1 of x equals 5/2 x plus 5. Did anybody get like 2.5 instead of 5 over 2? No? You left it in fraction form? Okay. And graphing the two functions, if we graph this first one, where do we start on this one? -2. And we have our rise over run of 2 over 5. So it looks something like this. So like this. And then this other one down here, what is that one? Where does this one start? Our y-intercept, 5. It's kind of harder to go up 5 and over 2, so what would you have to do instead to graph this one? You got to go down 5 and over 2 like this, right? Down 5 and over 2, so something like this. So things are going to look like this, kind of. Okay, does this look like this is a good reflection about y equals x? It does, right? Have you tried doing those in the calculator to check in your calculator? I've seen you on the Addy using the calculator. Anybody else? Do you know how to do this in the calculator? No, let me show you. What happens is we have 2/5 x minus 2 and 5/2 x plus 5. So 2/5 x minus 2 and I just put in 0.4 instead because 0.4 is 2/5, right? And then we graph this one, and so we see this thing over here, right? And then, so like this I think was the original one, right? And then over here we had 2.5x plus 5, right? So we get a good looking reflection, right? And Addie with her calculator has it in living color and Marcus too, okay? And you have one of those color calculators too. Oh man, this is like upscale. All right, questions on that? And we could do composition also on this, but we won't. Let's just go on to number 11. But how are we going to go on to number 11? How is that going to happen? We have to have things happening. Yes. Good job. Okay. So now we go to number 11. number 11, we have, this applies to number 11 and 12. For the given function, determine the domain of the inverse function, then find an equation for the inverse function and graph it. Interpret the meaning of the inverse function. So my recommendation on this would be to find an equation for the inverse function first, and then graph, and then ascertain the domain. All right? So how do we go ahead and find the inverse of this function? We have the equation a equals 1/2 times 20, and then h over here. What are we trying to do with this one?
Find the height.
Okay, we want to find the height? You said, okay, Jay, very good. Yes. Jay says find the height. You don't mind being called Jay, do you? Jay is a very special name to me. My brother's name is Jay. So I think that's a good name for you. All right. All right, find the height. Very good. Okay, how do we find the height of this thing?
We had to solve for h.
Solve for h. Okay. All right. We're getting places. Okay, then let's go solve for h. How do we do that?
So it's just a and h.
Well, we're just going to leave h here and just solve for it where it is. Okay. Remember at the beginning of inverses, I talked about Fahrenheit to centigrade and all that, and we had an equation for Fahrenheit, but when we solved the centigrade one, we left that centigrade right there and just got that big C by itself, right? This is the same thing. We're going to just get that h by itself and manipulate everything else. Okay? All right, good job. That's a good observation there. What next?
We take 1/2 to 20.
Pardon me?
We do the 1/2 to 20 times 20.
Okay, which is
10.
10. Okay. Everybody okay with that? Okay, then next. Yeah.
Divide the 10.
Divide by 10.
Or the I, yeah.
So we get h equals a over 10, right?
Yep.
Or you could also say
1/10
h equals 1/10 h, yeah. Or 1/10a, excuse me. Okay, so now we have a function, and these are both correct. Okay, and then how do we graph this function?
The base is 20.
So we graph this function here. What is our rise over run?
1 over 10.
1 over 10. So we can go up 1 and over 2. Well, that would be 2 to 40, right? We need to go to 4 to 40. So about here, right? Okay. And then 8 to 80, 12 to 120, 16 to 160. So the graph's going to look like this, right? Okay, so is that our graph? Does that look good? Okay, and then what is our domain for this thing?
Zero to 160? Or is it 0 to 16?
So 0, and really we have our arrow here, so what is this really going to be?
Oh, yeah.
Infinity, right? Now, next question, are we going to have bracket 0 or parentheses 0?
Bracket.
I think bracket 0. So bracket 0, you're saying? Okay, this right here, the domain is listed there that Jay gave us, that's the way the book gives it. But my preference would be to do this, to have this greater than 0, less than infinity. Why would I want to use parentheses maybe instead of bracket? This is valid. But why would I think maybe parentheses?
Because we don't know if it's equal to or not.
Because if you have 0x, you have 0y, which is nothing.
Yeah, so I think Ben's getting to it. What happens is that if you essentially have a point. If you're right at 0, you have a point. And if you have a point, do you have any area? Do you have a triangle? No. And so this thing doesn't officially start becoming an area and a triangle with having a height and area until we're greater than 0. But the book, like I said, has this, did it this way, which is, they did set notation too, but that's okay. Now I want you to do this one, number 12. Go ahead and do that one. It's very similar to number 11. Okay, this is what I got for the inverse function. Does that look right to you? And then the graph of that function in our domain. It's going to be
0 to infinity.
0 to infinity. And do you like the bracket for this one? You don't? Well, I had a good argument for the bracket. It was in Steve-O. He said that you could have a case where you have 0 because it's possible to have 0 area, in which case you're not going to have any coverage. So 0 is, in this case, still a possibility. I mean, you could argue either way, right? Like, what does it matter if it's 0? But again, this is like the book has it, so. Questions on this one? Very, very simple. Okay, now we're at the 13, 14. the graph of a function is given, tell whether the function's inverse is a function, and explain your reasoning. If the inverse is not a function, tell how you can restrict the domain of the function so its inverse is a function. So, on that graphical organizer that Connor has right on his desk, what was one of the 6 things that it says on there? The inverse of a function is,
Not always.
okay, Connor said it is not always a function. And that's what this is getting at here. Okay. What kind of function do we call this one on number 13 represented by the graph? That's what kind of equation that produces that kind of graph? This V shape.
Quadratic.
Now, a quadratic has similar characteristics as like same end behavior. Like quadratic, though, is going to be curved like this, right?
Linear?
Now here we have a V shape. Well, it's kind of like linear.
It's the absolute value one.
Yeah, okay, Ben just said absolute value function. That's right. So, what we're being asked the question, is the inverse of this absolute value graph function a function? Why not? Ben is shaking his head left and right. Why not?
Would go to the y equals x line. The left side would go under the right side.
Yeah.
The right side would change.
So yeah, let's go look at this here, okay? I'm gonna draw this in green. So we have this right like this, right? And so its inverse is gonna be like this. And then it's gonna go something like this, right? Okay, not very accurate drawing, but you get the idea, right? And so this green thing right here, is that a function? No, it's not. And so there's a test we have for that. Okay, so who said vertical? Okay, Bryce says vertical line test, but it's not vertical line test in this case. It's called that's a horizontal line, right?
Horizontal line test.
But horizontal line test, okay? It's like the vertical line test, except use the horizontal line test to tell if its inverse is a function. If in this case, does this thing pass the horizontal line test or fail?
Bill?
Fails, right? So fails, that means the inverse of this thing here is not going to be a function. Okay, so yeah, so Bryce is right to mention vertical line test, but it's like we turn it sideways 90 degrees and make it the horizontal line test, essentially.
So one is always going to be not a function.
Yeah, so what it is, we say, for this one, we say, for 13, we'll say f -1 of x is not a function. And explain your reasoning, right? How would you explain your reasoning? Ben he explained that if the thing reflected, it would look something like that. But how could you say that? How otherwise it might be easier to say that you failed, that you weren't that the inverse is not a function.
Because it doesn't pass horizontal line.
Yes, very good. In fact, Gabby just said it here. She says does not pass the horizontal line test. So I'm going to just change that. I'll say fails the horizontal line test. Okay, so that would be that one. Okay, and then for number 14, is the inverse of number 14 a function? Is the thing passing the horizontal line test?
Yes.
Yes, it is, passing the horizontal line test. Touches only once. So, for 14, f negative 1x is a function and we'd say passes the horizontal line test. And then you could get into what the graph of this thing looks like also, which is going to look something like this, if I could draw right. See this red one? That reflects about the line y equals x. Okay? All right. Let's go on to number 15. Multiple response. Identify the domain intervals over which the inverse of the graph function is also a function. Select all that apply. So this is really related to number 13 and 14. So if we looked at the whole function here, all the way from the left side to the right side, is the inverse of this function a function? Yes, no, maybe? You don't know? Okay, let's go look at this again. Okay, we're gonna borrow Bryce's horizontal line right here. Okay, Bryce, you got this horizontal line from problems 13 and 14, right? And we bring this thing up. Does this thing pass the horizontal line test? No, it doesn't. But it does at certain places, right?
Yeah.
Like for here it does. And if you have like between 4 and infinity, it does for this part. But for the whole thing, does not. So here, we know it does not because for the whole thing. But what, are there intervals for which this thing does pass a horizontal line test?
8 to infinity.
Would you say?
8 to infinity.
Okay, so Bryce says 8 to infinity because if we take this piece here, right? This definitely would, because just this piece from 8 to infinity would. So that's a correct answer. All right. Good job. What? Any others you see here?
4 to infinity?
4 to infinity.
Never mind. Negative 4.
Well, negative 4 to infinity. Okay, here's negative 4. So let's go from negative 4. So you got negative 4 to infinity. Is that passing?
It would have to be negative 4 to negative.
Yeah.
Negative 4 to
Okay.
negative. Yeah, so this one here, this one does not. Okay, any that do. Would 4 to infinity work?
Well, they're on top of, yeah, they're on top of.
Yeah, because it'd be this piece right here, right? What about 0 to infinity?
Yes.
You
No,
think so?
no, I wouldn't, no.
No.
Yeah, see, I'm thinking that this one is barely disqualified because right here, what happens at right here, you touch twice, right? So this is just a bare disqualification. And negative infinity to 4, does that work?
4 to 8.
Okay, 4 to 8 works, right? Agree with that, 4 to 8? What about 0 to 8?
No.
No. Okay, so now we have E and F look quite similar. What do you think for E and F?
E, yes, F, no. Or, wait,
E, yes, F, no,
no, yeah, possibly.
possibly.
You can have the same thing.
No.
Because of the bracket and
Oh, I didn't see the bracket.
I'm going with even this,
I don't know.
Which one of these would pass? One would pass and one would not.
E would pass, I think that's the bracket, we're on the 4 side.
Okay, let's look at E. If you go from negative infinity to 4, so you negative infinity, and then to 4, you have to pop right up here. For bracket, you have to pop up here. So what happens when you pop up here? Fails. Okay? So this is not going to work. Is this one here going to work?
Yes.
Yeah, because you didn't, because you just went to negative or positive 4. So that's that one. Okay, 16, draw a conclusion. Identify all linear functions that are their own inverse. Is there a linear function you can think of that's its own inverse? What'd you say, Bryce?
Wouldn't like just one x be its same inverse, correct?
Okay, so Bryce says f of x equals x is the inverse of itself. Does that sound good? Yeah, it really does, because what you're looking like for inverse functions, you're trying to look for the line that reflects about y equals x. Well, the only thing I can think that's in one equation that's going to do that is this one right here. So that's the only one. Okay, 17, make a conjecture. Among linear functions, excluding constant functions, quadratic functions, absolute value. So linear functions. So you give 4 types of functions: linear, quadratic, absolute value, and exponential functions. Which types of functions do you have to restrict the domain for the inverse to be a function? 4 types. Are there any that you have to restrict the domain for it to be a function? Look at problem 13. Problem 13, did you have to restrict the domain?
Yeah.
You did, right? So,
Absolute value.
absolute value function. So, say f of x equals absolute value of x. Okay, so that's one of them. Okay, and then is there another one?
Exponential.
Okay, exponential, let's see what that looks like. And we're going to do that later this year. The exponential function looks like this. Does that look like the inverse of this function is a function? Yeah, it does. So we're not going to have that on the list. What other one is there? How about quadratic, right? Quadratic would also not qualify either. For the same reason the absolute value does not qualify. And I think that's going to be it on that one. So yeah, absolute value and quadratic. And the last one here, 18, is find the error. So just go ahead and quickly see if you can solve this one and look at what the error is for 18. The student did this problem here. Okay, did you find the mistake for this one?
They didn't divide the y-intercept?
So Connor says he didn't divide the y-intercept.
They should have divided by 2 instead of divided by 2.
Should have divided by 2?
Yeah.
Okay. So let's go ahead and go. So for this one, he had like x equals 2y plus 1, is that right? And then, so 2y equals x minus 1, then divide by 2, you should get y equals x over 2 minus 1/2. So it didn't divide the 1 by 2, right? Okay. All right. So that's it.